choose difference of squares as one of our types of factoring when you have two terms and they're both perfect squares. By both being perfect squares, that means that you can square root them evenly. So the square root of x squared is just x, and the square root of 25 is 5. You write that in brackets, and then you write it again in brackets with the opposite sign. So now we're going to write it with addition. And that there is factored fully. We can show you how that works down here with a quick check. Just remember that you can always check your factoring to see if you've done it correctly by expanding your work. FOIL, as you remember probably from last year. So x times x is x squared. And then we do our outside terms. X times 5 is positive 5. Negative 5 times x, oops, there was an x there, excuse me, negative 5x. And then our last terms, negative 5 times positive 5 gives us negative 25. And what will always happen for these, you can see that our two inside terms are going to equal 0. Positive 5 minus 5 is 0. So we're always going to be left with x squared minus 25. Now I've checked to see that I've done my work correctly. A good thing just to point out and remember is that when difference of squares can work is only when your two perfect squares are separated with subtraction. This does not work for addition. So we'll do another example here. Our first term has a perfect square in it. It actually has two perfect squares because you can square root the 4, which is 2, and square root x squared, which equals x. The square root of 100 is 10. So I bracket that off. And then I write it again with addition. Now what I need to be very careful of here is that I have two terms that aren't factored fully yet. I can still common factor out 2 from every term. So like reducing fractions, you always want to be sure that you factored fully. I can factor out 2 from this binomial as well here. And then I'm just going to clean it up because 2 times 2 equals 4. And then I'm left with x minus 5, x plus 5. To have saved this step here, we also could have done this question by common factoring the 4 out first because 4 goes into both terms evenly. It works either way. It's just that if you miss the common factor step, it's important to realize that you still have to factor from there.